All right, this is Mr. Smith here. This is Algebra 2, Section 4.8, kind of a culminating point of Chapter 4, the quadratic formula, and looking also at a special feature of the quadratic formula called the discriminant. So just to start right out of the way, get it out of the way with, this is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. As long as we have a quadratic that's written in this format. So we need to have a quadratic that's written in the form ax squared plus bx plus c equals 0. This also means that we're going to have to set the quadratic equal to 0 so that we can pull out what a, b, and c are. So one more time, the quadratic formula, it's written right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Two observations. Number one, the quadratic formula comes from section 4.7. Okay, we saw that at the very end of section 4.7. Where does this come from? We complete the square on this guy, and if we complete the square all the way through and do a little simplifying, we get out what is the quadratic formula. Number two, this is just a word of caution. Okay? Whatever this b value is, the first thing here is negative b. Just got to be careful on your sign. And then minus 4ac also gets a little tricky, but we need to make sure we're watching our signs very closely. Okay, that'll have a huge impact on how the solutions work out if you mess up on the signs. Okay, so here's the first example. Okay. Nice looking quadratic equation. In this example, I'll go ahead and subtract the 2. So x squared plus 3x minus 2 equals 0. And now for some of you who aren't really familiar or haven't had much experience with the quadratic formula, I would encourage you to actually write out a, b, and c. Okay, so a is 1, b is 3, c is negative 2. Also, the first few times that you do these problems, it's probably beneficial to write out exactly what the quadratic formula is. After you feel like you have the hang of it, or after you feel like you have it memorized, there's no need to write it out every time. You can just jump right into it. So in this case, negative b, so it'll be negative 3, plus or minus 3 squared, which is 9, minus 4 times a, which is 4, times negative 2, which is minus negative 8. This is what I was referring to when I said you got to be careful of your signs. Okay, right? It was 9 minus 4 times a times c, which happens to be negative 8. So obviously we're going to be adding these here in a moment. And then this is all over 2a, so this is just all over 2. Okay. So now we'll just simplify, right? We're going to do some adding. We'll do any simplifying we can do. And that's what I mean when I say this is arithmetic now. Okay. Negative 3 plus or minus the square root of 9 plus 8, so 17, all over 2. And that represents our two solutions. Now, the only other way that you might see this formatted is they may break it down, if you had a multiple choice exam, they may break it down like this. Remember that both numbers get divided by the 2. So we have negative 3 divided by 2, and we have radical 17 divided by 2. And if one of these were to simplify farther, we could do that. In this case, it's not worth it. So the two answers, the question was, what are the two answers? And the two answers are negative 3 halves plus radical 17 over 2, and then negative 3 halves minus radical 17 over 2. Okay, and again, you can leave it just like this. This formatting is fine. You don't actually have to write two separate answers. Okay? All right, let's look at another. So here we go. Negative x squared plus 4x equals 5. Again, the formatting piece of this shouldn't be a big concern for us at this point. You guys have overcome a lot more difficult math. We just need to set this whole thing equal to 0. Set the whole thing equal to 0. So we'll subtract out the 5 to do so. Negative x squared plus 4x minus 5 equals 0. Up until this point, we've always tried to get rid of that negative first term. The negative first coefficient, the negative 1 in front of the x squared. We've almost always tried to get rid of that for all of the other methods. but we don't have to do that for the quadratic formula. Okay, the quadratic formula will take that into account as long as when I define A, I say A is -1. So A is -1, B is 4, C is -5. Now, if you don't like that, if you didn't want to use those values, you could have multiplied everything by -1. Right? So if you take the equation and multiply everything by -1, that'll just change all of the signs. That'll change all of the signs here, but you will still get out the same solutions using the quadratic formula. So again, using the quadratic formula, x equals -b, so -4, plus or minus the square root of b squared, so 16, minus 4 times a times c. So a times c is +5, times 4 is 20. All over 2 times a, so -2. Okay. We now go through and do the arithmetic, right? 16 minus 20, that's going to be -4. So again, -4 plus or minus the square root of -4 all over -2. Now, from our experience in section 4.6, the square root of -4 is just, we can write the square root of -4, maybe I'll do that down here. Square root of -4 is the square root of 4 times I, but the square root of 4 is just 2, so this gives us 2I. Okay, so I can rewrite my expression now as -4 plus or minus 2I divided by -2, divided by -2. And now this is where we want to take it one step farther. We'll want to simplify this fraction. And watch what happens if I write this. I get -4 over -2 plus or minus 2I over -2. And of course, -4 divided by -2 is +2. And 2I divided by -2 is just +-I. Okay. And again, there represents the two solutions to our quadratic equation. Okay, so one more time, we set it equals 0. We pull out A, B, and C. We plug them into the quadratic formula. We do a little bit of arithmetic. Careful here, we get a negative under the square root, so that means our answer should be imaginary. And now the last step is just to do a little simplifying of the fractions, remembering that both the 4 and the 2I get divided by -2. Okay, so here are two problems that I would like you to work on right now. Okay. So if you're watching the video at home, if you would just stop the video and go ahead and work through these two problems. If you are in the class, this is your cue to start going. And I'll pause the video in just a second, and I hope you'll do the same. One thing to note, remember these are equations. So we can do whatever we want to one side as long as we do it to the other, including trying to make these problems easier and the numbers smaller to work with. So for instance, I see in problem 1, all of the numbers are even, so it may be beneficial to divide by 2 early on just to make the numbers that we're going to work with smaller at this point. Well, you can transfer the 16 and then divide by 2. You can divide by 2, then transfer the 8 at that point. It doesn't matter that piece. But I would encourage you to simplify the problem if you can. All right, so you may pause the video now and begin working. All right, welcome back. We're taking a look at these two problems. And so on this guy, on number 1, I went ahead and shifted the 16 over by adding it. And I divided out into 2 just to make my life a little simpler, a little easier. And I noticed something. This factors. So if you want to branch off at this point and say, well, I can do the quadratic formula, but factoring's quicker, go ahead. Just go ahead and finish it off with factoring. Otherwise, if you don't see that, it's fine. If you don't want to do factoring, if factoring is like a curse word to you, use the quadratic formula. It'll always work. -b plus or minus b squared minus 4ac all over 2a. And this gets us down to a point where we get -6 plus or minus 2 divided by 2. So -6 minus 2 is -8 over 2. -8 over 2 is just -4. -6 plus 2 is -4. -4 divided by 2 is just -2. And there you see we get our two solutions. Okay. On the next problem, again, we go ahead and shift the 7x and the 25 over to the other side. Plug all the numbers into the quadratic formula. So careful, one word of caution, right? B here is negative 20. So when I put negative 20, that should give me a positive 20, plus minus 20 squared 400, minus 4ac, which is also 400. So the whole square root term just drops out, right? Because I basically get the square root of 0, which is 0. So we don't even have to consider this anymore. And all we're left with is 20 divided by 4, which is 5 halves. And this is the only case where we get one solution, but in mathematics we say it's one solution, x equals 5 halves, with a multiplicity of 2. And it's kind of our way of getting around this idea that we only get one solution. But since it happens twice, we kind of still want to keep the idea that there are two solutions to quadratic equations. Okay. All right. So I hope that after doing some of these problems, you begin to see that the square root, right, the square root of the problem really determines what our solutions are going to look like. And I'll explain that more in just a moment. Here are a few more practice problems if you want to do on the video. Please do so. But the square root of the problem of the quadratic formula really determines whether we're going to have two real roots, two imaginary roots, or one real root. Okay? And so because of that, we give it some importance in mathematics, and we call this b squared minus 4ac. It's called the discriminant. Okay? The b squared minus 4ac part. So just this number right underneath the square root, we call that the discriminant. And it can tell us basically what our answers are going to look like. Namely, if the discriminant is positive, it means we'll get two real solutions. So we can look at the graphing calculator and see where the intersection points are. We'll have two real solutions. If the discriminant, the b squared minus 4ac part, is negative, we'll have two imaginary solutions. Okay, so we'll have two imaginary solutions. If the discriminant is 0, we get one real solution. Okay. And so you can go back and look at the previous problems that we've seen and look at the square root, and just the number underneath the square root, b squared minus 4ac, we call that the discriminant. And if the discriminant was positive, we would have gotten two real solutions. If the discriminant was negative, you'll see that our solutions, we had two of them, but they were both imaginary. And if the discriminant was 0, if the square root piece drops out, we only get one real solution. So if you go back again and look at the previous problems that we've done, you'll see that this holds true. The reason that this is kind of matters or is a shortcut is because sometimes questions will ask you, are there two real solutions or are there two imaginary solutions? And so you can answer the question without having to do the entire quadratic formula. You can just use the discriminant to answer the question. So here, for instance, they say, give the number and type of solutions of the equation. Okay. Well, this would be one time where you wouldn't have to use the full quadratic formula. You could just use the discriminant to assist you. Okay. However, personally, I'd much rather ask you, what are the solutions? I don't care if there are two real ones. I want to know what the real ones are. Right? I don't care if there are two imaginary solutions. I want to know what they are. So for my sake, for my class, I don't do this. I won't ask you this question. However, if you're in a different Algebra 2 class watching the video, that may not be the case for you. But again, I don't find the value in knowing if there are two real solutions or two complex solutions. I want to know what the solutions are, and therefore you have to use the full quadratic formula to be able to answer that. Okay? So I'm going to skip these, but if you'd like to answer them, you're more than welcome to. Okay. And so that brings us to a problem, an application of quadratics. And this is really what I want to focus on for the remainder of our time together. And so here's the scenario. We have a juggler. He tosses the ball into the air. The ball leaves the juggler's hand 4 feet above the ground, and he throws it up at an initial vertical velocity of 40 feet a second. And as a side note, I'm curious how fast that really is. How fast is 40 feet a second? It seems pretty fast to me to throw a ball up into the air, but that's just my side tangential thought. So the juggler catches the ball when it's at a height of 3 feet. So what happens is he throws it at 4 feet and catches it a foot lower after it's gone through the motion in the air. And so the question is, how long is the ball in the air? And so we have this model. Okay. A model is nothing more than an equation, and this equation has some variable inputs that we need to go through and define. So first of all, h here, this is the final height, so I'll call that FH. This is the final height of the ball. This whole formula, this whole model is based in t times seconds. Okay. This is called V naught. Anytime we have a variable with a subscript 0, we call it V naught. So this will be called H naught. And V naught is the initial vertical velocity. Okay, so V naught is the initial vertical velocity. And H naught, right here, is the starting height. Okay, so FH is the final height. The FH is the final height. The T is the variable time in seconds. V naught is the initial vertical velocity. And H naught is the starting height. I really like this problem. You'll probably see it again, but you don't need to memorize the formula. Okay, you need to know what each of these variables mean and what the spaces are for, but I'll give this to you. Okay, I'll give this to you. And so now we need to plug in the context into this model. Okay, we need to plug in the context into the model, and that'll look something like this, right? So the final height of the ball is 3 feet. Okay. We get negative 16t squared plus v naught. This is the initial vertical velocity. So here, the initial vertical velocity is 40 feet a second, times t, which is our time, plus h naught, which is our starting height of the ball, so that's the 4. And so basically, this model creates an equation that we can now solve to find how long the ball was in the air, which I know is a very pressing question. Most of you chomping at the bit here to figure that out, right? That desire to know how long the ball was in the air. One other thing before we get on to solving this equation is this 16. We have this 16 here in the model, and it's just a good exercise to consider, what does that 16 represent in real life? Okay, right? Think about all these numbers here represent something, some value of real life, right? The 4 was the starting height. The 40 was the initial vertical velocity. The 3 is the ending height. T is time in seconds. So what is the negative 16 in real life? What is that doing? Go ahead. Okay, so maybe a velocity of it falling. It's close. You're very close there. Any other takers? Go ahead. Yeah, so in this case, this negative 16 is gravity. This is the effect of gravity, and somehow it's negative 16. Taking that a step farther, it's negative 16 feet, and so somehow this is what gravity is, and there is an explanation. That's for a different class, but for now you should know that this is part of the problem, and this is representing gravity. So if we do the same problem on the moon, this negative 16 should probably be something different. But now we're ready to solve it. And so at this point, I'm going to pause and let my students solve it, and I hope you'll solve it at home. And I would encourage you probably to use the quadratic formula. I doubt this is going to factor. So why don't you go ahead and do that. Remember that your answer should be a decimal answer, okay? Because we're going to be talking about seconds, and if your answer was, for instance, square root of 5 seconds, I'm pretty sure most of you would have no idea how long that is. Okay, so I'd much rather see a decimal answer here instead of an exact square root answer. All right, so give me 3 decimal places, 2 or 3 decimal places, and we'll go from there. So I'll go ahead and pause the video now and let you guys work on it. Okay, so hopefully you have worked your magic with the quadratic formula. Remember, setting it equal to 0. We figure out A, B, and C. We plug them in, and we start going with the arithmetic. A few things to see. Number 1, we get the square root of 1664, and usually we'd want to keep that exact. We'd want to keep the square root in here, but since we're working with an applied problem that we want to receive a decimal answer for, it's really worth it at this point to just convert this to a decimal and continue on. The next thing to see is that we'll get 2 solutions from this, but one of them will be negative, and that doesn't make sense in our problem. right? It doesn't make sense to have a negative seconds happen in the problem. Okay, so we can eliminate that. The last thing to see is that we can consider this problem graphically. And so if I set both of these pieces, the 3 and this expression here, equal to 0, what you'll see is there's the 3, and now the other piece is negative 16, and I'll use x here, so negative 16x squared plus 40x plus 4. And this green graph is the graph actually representing the height of the ball. Okay, so what you can see is here's the ball starting at here's the ball starting at 4 feet. Right, the ball's released from 4 feet. It goes up, and you can see it goes up and up and up, and it makes an arc. And this is actually representing the height of the ball. And it comes back down, and he catches it at 3 feet. And so all we need to do is find the intersection point there. So we go Menu, Analyze Graph, Intersection. We go left, we go right, and you can see we get an x value of 2.52, meaning it takes 2.52 seconds for the ball to be released from 4 feet. It makes it arc all the way up and comes back down, and he catches it at 3 feet. Okay, the graphing calculator is a tremendous asset. I encourage all of you to use it. So this concludes section 4.8. Thanks for your attention. Mr. Smith signing off.